Hello, I'm Zachary Frederick, and my partner is Danny Santos, and our project was to control a quadcopter over Wi-Fi for Dr. Zalewski's Cyberphysical Systems class. The objective of our project was to control the Hubsan X4 quadcopter over secure Wi-Fi connection. The project consisted of the quadcopter, an Adafruit ESP8266 board connected to an AMIC A7105 transceiver, and the Blink Apple application to allow the user to control the quadcopter. Some client-side requirements where the Blink Apple application shall be able to connect to the ESP8266 board through the authentication token received by the user. The Blink Apple application shall be able to send commands to the motor through the ESP board. The Blink Apple app shall be able to connect to the quadcopter through the secure Wi-Fi. The Blink Apple app shall be able to control the lights of the quadcopter by pushing the lights button on the Blink Apple app. Some ESP side requirements, where the ESP board software shall be able to send commands to the quadcopter motor through a secure Wi-Fi. The ESP board software shall be able to receive flight information from the quadcopter. The ESP board software shall be able to connect to a secure Wi-Fi, and the ESP board software shall be able to interpret commands received from the Blink Apple application. The dynamic design description of our project is shown below. After the user inputs their authentication token, Wi-Fi name, and Wi-Fi password into the Arduino application and uploads it onto the board, the user then selects the bind button on the Blink application to connect to the quadcopter. They are able to test this connection by pressing the lights button on the Blink application and controlling the lights of the quadcopter. Once the user is connected, the user can send commands to the quadcopter by moving the joysticks as they please. The Arduino application interprets those commands and sends the commands through the Wi-Fi to the quadcopter. The quadcopter will move to the commands of the user while they move the joystick. Some pre-flight initial setup can be shown below. First, the user needs to enter the authentication token, their Wi-Fi name, and their Wi-Fi password into the Arduino app, and then upload that to the ESP board. The next two pictures show ours and a more detailed design of the wiring for the ESP board to the A7 transceiver that allows the ESP board to connect the transceiver and then eventually connect to the quadcopter. Next, you will see two demos of our quadcopter in flight. First, to connect to the quadcopter, we hit the bind button and turn the lights on to make sure we're connected, and then we can take off. We were able to control the quadcopter, but as you can see, not very well. We were outside, so the wind really affected the controlling of the quadcopter and blew it all over the place. Now is the second video of it. We're already connected, and we have a takeoff, and we're able to fly around as the user pleases. As you can see, Danny's controlling the quadcopter, trying to lift off from the ground, trying not to get it blown too far away. You can now see the test results for our project. In test case 1, the ESP8266 board successfully connected to the Blink Apple application. In test case 2, the ESP8266 board successfully interpreted and sent commands to the quadcopter through the Wi-Fi. In test case 3, the ESP8266 board successfully connected to a secure Wi-Fi. And in test case 4, the Blink Apple application was able to connect to the quadcopter through the ESP board and control the lights of the quadcopter. In conclusion, our project met all the requirements that were set before implementation of the project. The quadcopter was able to be controlled through the use of the Blink application. However, it was hard to control it since the quadcopter was so small and it was so windy outside. Some improvements to the project could include adding pieces of hardware onto the quadcopter, such as a camera, that would allow the user to see where they're flying, or connecting to a better quadcopter so that the user can have better control in all situations